So, hello and welcome back. So in this video we want to do some exercises related to basically these different algebraic methods of solving these equations. And let's say that you have, for example, a pair of linear equations. So for example, x plus y is equal to 14 and x minus y is equal to 4. Okay, and you want to solve this method of this pair of linear equations by the method of substitution. Okay, so by the method of substitution, if I call this 1 and if I call this 2, what I can do is that, for example, I can take 1 and express one of the variables in terms of the other variable. So for example, I can write x plus y is equal to 14, and then I can write x is equal to, here in terms of y, negative y plus 14. So that's x in terms of y. Now I can substitute the found value of x, in the previous step, in either 1 or 2 to find y. Okay, so the value of x that I found over here in terms of the value of x in terms of y was x is equal to negative y plus 14. Okay, so now I can use, for example, 1 over here, and it gives me x plus y is equal to 14. Now here the value of x is equal to negative y plus 14, plus y is equal to 14. Okay, so it's not so as you can see, what this means is that basically this and y and minus y you can cancel out, and you get 14 is equal to 14, which is equal to true, which is true. That means that that most probably means that this system of I'm sorry, I used the same equation. I'm sorry. I was kind of and what I wrote here was basically not right. So when you want to substitute the found value of x in the previous step, so in the previous step the value of x in terms of y I got it from equation number 1. So I have to substitute it either not either in 1 or 2, but strictly in 2. Otherwise the same thing happens here. I'm going to say in 2 step, in substitute the found value of x in the previous step in 2 to find y or x, basically any of them basically. So basically now, since in the previous step I used equation number 1, in this step I have to use equation number 2. So using equation number 2, what I will get is x minus y is equal to 4, and the value of x over here was negative y plus 14. So negative y plus 14 is equal to 4. I'm sorry, I made a mistake here. So negative x is equal to negative y plus 14, and you have a negative y over here is equal to 4. So negative 2y plus 14 is equal to 4, and negative 2y is equal to 4 minus 14, and that's equal to negative 2y is equal to basically negative 10. So y is equal to negative 10 over negative 2, which is equal to 5. So the value of y is equal to 5 here. Okay. So now what you can do is that substitute the value of y, in either 1 or 2, to get basically the value of x. So you can use 1 or 2, it doesn't matter which one you use because you already have the value of y. So basically using, for example, 1, what you will get is that x plus y is equal to 14, and x plus 5 is equal to 14, because the value of y over here is 5. So x is equal to 14 minus 5, and x is equal to 9 basically. So that's the value of your x and y over here. X is equal to 9, y is equal to 5. Let's do one more of these. Okay. So let's say that you have, for example, s minus t. You have s minus t is equal to 3, and s divided by 3, and s divided by 3 plus t divided by 2 plus t divided by 2 is equal to 6. Okay. So what you can do in order to make things a little bit simpler, you can multiply basically all of the terms in this in number 2. Let's call this number 1 and number 2. In number 2, you can multiply everything by a factor of 6 in order to get rid of these two denominators. So I'm going to write this as basically 6 times s divided by 3 plus t divided by 2 is equal to 6. Okay, so that's going to give me 6s divided by 3 plus 6t divided by 2 is equal to 6 times 6, which is equal to 36. Now 6 divided by 3 is equal to 2, so that's 2s, 3t is equal to 36. Now this way you can get out of the denominators, and then it's easier to work with the two equations. So now I can write this pair of linear equations as s minus t is equal to, and I call this equation number 3, for example. So s minus t is equal to 3, and then instead of 2, I'm going to use the other version of 2, which is basically 3 over here. So you have 2s plus 3t is equal to 36. So I'm going to call this still 1 and 2. Right. So now you can use, and remember that we are using the method of substitution. Okay. So what I'm going to do is that find, for example, s in terms of t from 1. Find s in terms of t. So number 1 is s minus t is equal to 3. So s is equal to t plus 3. That's basically the value of s in terms of t. Now you can substitute. Actually, this is supposed to be equal to, this is 3, not 2. Okay. Now what you can do is that you can substitute equation, for example, let's call it 4. Substitute the value of s in 4 in one of the in basically not, you cannot use 1 anymore because basically the value of s you already got it from 1, so you have to use 3 over here. So substitute the value of s in 4, which you got it from 1, in equation number 3. So equation number 3 is 2s plus 3t plus 3t is equal to 36. Is equal to 36. Now s is equal to t plus 3. So that's 2 times t plus 3 plus 3t is equal to 36. Is equal to 36. And that is equal to 2t plus 6. 2t plus 6 plus 3t is equal to 36. So 2t plus 3t is equal to 36 minus 6. 5t is equal to 30. So that means that t is equal to 30 divided by 5, which is equal to 6. So t is equal to 6. Okay. So that's the value of t over here. Now you can use the value of t that you found over here and use it either, for example, in 1 or 3 or even in 2, for example, in order to get the value of s. So since 1 is the simplest equation that I have here, I'm going to use 1. So use 1 to find s basically. So I have s minus t is equal to 3. So s minus t is equal to 6 is equal to 3. So s is equal to 3 plus 6, which is equal to 9. So s is equal to 9. So that's basically the second. S is equal to 9 and t is equal to 6. So the next question that we have is let's do one more of these and let's see. So let's say that you have well, there is for example, there is this question, square root of 2 times x plus square root of 3 times y is equal to 0, and square root of 3 times x minus square root of 8 times y is equal to 0. So you need to do something in order so that basically your equations get a little bit simpler. And what you can do is that, for example, over here, if I call this equation number 1, equation number 2, so let me see first. Square root of 2x plus square root of 3, y is equal to 0, and square root of 3x minus the square root of 8y is equal to 0. Okay, so what you can do, let's try and see what we can do here. So let's say that you have, let's say that in 1, basically from 1, you want to find the value of, you want to find x in terms of y, So that would be square root of 2x is equal to negative square root of 3y. Negative square root of 3y. And that means that x is equal to negative square root of 3 divided by square root of 2 y, right? So that's basically x in terms of y. Maybe we can actually, we could actually use this thing in order to, and then you can substitute the value, this value of x in 2. Let's see what happens if we do that. So substitute x in 2. If you substitute your x in 2, you will get basically square root of 3 times the value of x, which is negative square root of 3 over square root of 2 times y, negative square root of 8 times y is equal to 0. Now, what happens is that the square root of 3 times square root of 3 is equal to 3. So this is 3 over negative 3 over square root of 2 times y minus square root of 8 times y is equal to 0. And then your y is equal to, your y is going to be equal to, I think, y is going to be equal to 0, if I'm not mistaken, because square root of 3 times square root of 3 is equal to 3, and you have a negative sign over here, over square root of 2 times y minus square root of 8 times y is equal to 0. So now if I take a y out, and write it as negative square root of 3 over square root of 2 minus square root of 8 is equal to 0. So this cannot be equal to 0. This is some number. So that means that y is equal to 0. If I'm not wrong or anything. Number 5. Yeah, y is equal to 0. So now since y is equal to 0, you can then use this value of y. You can use y is equal to 0 in either 1 or 2 in order to calculate x. So number 1 is, for example, square root of 2x plus square root of 3, y is equal to 0. Square root of 2x plus the square root of 3y is equal to 0. Now since y is equal to 0, so that is square root of 2 times x plus basically y square root of 3 times y times 0 is equal to 0. So that means that the square root of 2 times x is equal to 0. That means that x is equal to 0. So that means that your y is equal to 0, y is equal to 0, and also x is equal to 0. Which is, I mean, I was expecting to get some values over here, but it seems that you just don't in the case of this problem. So let's do another one of these here. For example, let's say that you have 3x minus y is equal to 3, and 9x minus 3y is equal to 9, and you want to solve this pair of linear equations by the method of substitution. Okay. So if I call this, for example, equation number 1, if I call this equation number 2, you want to find, for example, probably in 1, find y in terms of x. So equation number 1 is 3x minus y is equal to 3. So negative y is equal to negative 3x plus 3, and multiply by negative 1, you'll get y is equal to 3x minus 3. So that's the value of y in this, in terms of x. Now what you can do is that substitute the value of y in 2, basically. Okay, so you have 9x minus 3 times y, which is equal to 3x minus 3 is equal to 9. So 9x minus 9x plus 9 is equal to 9. And basically 9 and 9 you can cancel out from each side. So let me see if I haven't made any mistakes here. So 9x minus 3y is equal to 9. So minus 3y, y was equal to 3x minus 3. So 9x minus 9x, I'm getting 0 is equal to 0, I suppose. Because these two you can cancel out. Yeah. See over here, what's happening is that these two you can cancel out here, and these two you can cancel out from both sides of the equation, and I'm getting 0 is equal to 0, which is true. That means that this equation, that means that this pair of, since basically this statement is true, that means that the pair of linear equations has infinitely many solutions. But no unique solution. Okay, so that was basically 3x minus y. So infinitely many solutions. Okay, now let's do another one of these. Now this time what we can do is so let's say you have 0.2x plus 0.3y is equal to 1.3, and 0.4x plus 0.5y is equal to 2.3. Okay, so you want to solve this system of equations using the method of substitution. Okay, so what you can do is that, for example, if you call this equation number 1, if you call this equation number 2, for example, in one find, for example, find y in or x in terms of y. Of course, the problem is that here we need a little bit more space. So I'm going to create a new sheet here and go up there. So the question again is 0.2x plus 0.3y is equal to 1.3, and 0.4x plus 0.5y is equal to 2.3. So again, let's call this 1 and 2, for example. So let's say that in 1, find, for example, find x in terms of y. So if you want to find x in terms of y in 1, you write it as 0.2x. What you can do to make things a little bit simpler, you can multiply everything by a factor of 10. That way your numbers, you will get whole numbers there, and before you do anything really. So the first thing that I'm going to do in 1 and 2, multiply both sides of the equations, by 10, because then you would get, for example, 2x and 3x and 13 and 4 and 5 and 23. So then what you will have is that basically 10 times 0.2x plus 0.3x, y is equal to 1.3, and also 10 times 0.4x plus 0.5y is equal to 2.3, and then that's equal to 2x plus 3y is equal to 13, and that's equal to 4x plus 5y is equal to 23. Okay, now you can work a little bit more easily on these equations. Okay, so now I can basically call these two equations equation number 3 and number 4. Okay. And for example, since we are using the method of substitution, I can find, for example, x in terms of y. Find x in terms of y in 3, for example. So in 3, if you want to find x in terms of y, you can write this as 2x is equal to negative 3y plus 13, and then x is equal to negative 3y plus 13 divided by 2. That's basically x in terms of y in 3. And then you can substitute the value of x. substitute the value of x, basically in 4, for example. And what you would get is that 4 times x, which is 4 times this expression, negative 3y plus 13 times divided by 2 plus 5y is equal to 23. So you can simplify this 2 and 1 and 2. So you'll get negative 6y plus 26 plus 5y is equal to 26. So 5y minus 6y is equal to negative y is equal to 26 minus 26, which is equal to 0. I'm sorry, this is 23. This is 23. So this is 23 minus 26. Negative y is equal to negative 3, so y is equal to 3. So now you can use, for example, you can use basically substitute the value y is equal to 3, for example, in 3, for example, to get the value of x. In that case, 2 times x plus 3 times 3 is equal to 13, and 2 times x is equal plus 9 is equal to 13, and 2x is equal to 13 minus 9, which is equal to 4. So x is equal to 4 divided by 2, which is equal to 2. So x is equal to 2. So this was number 4 over here. x2, y3. And I think that's enough for this kind of exercise. And we have a couple more questions here. Let me go through these questions and see what we have, basically what we can do here. Okay, so now we have some word problems, and these word problems are, of course, always a good way to basically understand your algebra as well, and then you can basically use the equations in order to solve them. So the question is, the difference between two numbers is 26 and one number is 3 times the other one. So if you take the two numbers as x and y, then you know that the difference between the two numbers is 26. For example, if you take x is greater than y, then basically you can say that if x is greater than y, then the difference between the two numbers is 26. So then you can write x minus y is equal to 26. And one number is 3 times the other one. So if x is greater than y, so then you can write x basically is equal to 3 times y, because y is smaller than x. So I think this way we can solve this pair of equations. So let's see what we get, and we want to solve the problem using the method of substitution. So you can basically use equation number 1, for example. So you can write these as you can basically write these as, for example, in general form, x minus y minus 26 is equal to 0, and x minus 3y is equal to 0. Okay, so I take these as my original equations, and then they take this as equation number 1 and 2. Now, if I use equation number 1 in order to find, for example, x in terms of y, I would get x is equal to y plus 26. And then I can substitute x in equation number 2. So y plus 26 instead of x minus 3y is equal to 0. So y minus 3y is equal to minus 2y is negative 2y is equal to negative 26. So y is equal to negative 26 divided by negative 2, which is equal to 13. Which is equal to 13. Okay. So if y is equal to 13, you can now use y in any of these equations to get the other number. So 13. So basically x minus, for example, this equation over here, x minus y minus 26 is equal to 0. And if y is equal to 13, then x minus 13 minus 26 is equal to 0. So x is equal to 13 plus 26, which is equal to 39. X is equal to 39. So basically one of your numbers is 39, the other one is 13. Basically x is 3 times y, and the difference between these two numbers is 39 minus 13, which is equal to 26, which is basically what we were looking for here. So the second question is, let me create a new sheet over here. The second question is, the larger of two supplementary angles exceeds the smaller by 18 degrees. So the question is, the larger of two supplementary angles exceeds the smaller by 18 degrees. Find them. So let's say that you have two angles x and y, and let's say that x is greater than y. So x is the greater angle, y is the smaller angle. And here it says that the larger of two supplementary angles, the two angles are supplementary, meaning that x plus y is equal to 180 degrees. These are supplementary angles. And the larger of two supplementary angles exceeds the smaller one by 18 degrees. That means that the difference between the measure of these two angles is 18 degrees. That means that if x is the greater angle, then x minus y is equal to 18 degrees. Okay, so that's basically the two equations that you have. And of course you don't have to write degrees over here in your equations, as long as you know that these numbers are basically angle measures in degrees. So I call this, for example, number 1 and number 2, and from 1 you can find, for example, x in terms of y. So x in terms of y is x is equal to 180 degrees minus y, and then I'll substitute the value of x. I'll substitute it in 2. So I'll get, basically this is 180 minus y is equal to 18. And so that's 180 minus 2y is equal to 18. And so negative 2y is equal to 18 minus 180. So 18 minus 180 would be equal to 162, negative 162, that's negative 2y. So that means that y is equal to negative 162 divided by 2, by negative 2. These two will cancel out, and then you have 50, 81 degrees. So y is equal to 81 degrees. Okay. Now you can use this value in any of these equations to get the other angle. So, for example, 1, we said that x plus y is equal to 180 degrees. Or, well, we said that we wouldn't write the degree signs. So your x plus y, which is equal to 81, is equal to 180 degrees. And x is equal to 180 minus 81, which is equal to 99 degrees. So x is equal to 99 degrees. So you can see that x is greater than y, 99 degrees, 81 degrees. And if you add them together, 99 plus 81, it's going to give you 180. That means that they are supplementary. And this greater angle exceeds this one by 18 degrees, meaning that 99 minus 81 is equal to 8. 18 degrees is the difference. Okay, so that's basically how you could solve this problem. Or another example here is that the coach of a cricket team, this is an example about cricket, for example. So a cricket team, for example, a cricket team buys 7 bats. A cricket team buys 7 bats and 6 balls for 3,800 rupees. Okay, later on they buy 3 bats. Later on they buy 3 bats and 5 balls for 1750 rupees. Okay. You want to find the cost of each bat and each ball. So you want to find the you want to find the unit price. The unit price for the bats and balls. Okay, so let's take the unit price. So the unit price for bats, I take it as X. The unit price for balls, I take it as Y. Okay, and so and so I have basically 7 bats and 6 balls. So a bat was X, so 7 bats would be 7X plus 6 balls would be 6Y is equal to 3,800. 3,800, and then 3 bats, 3X plus 5 balls, 5Y is equal to 1750. And this is now a pair of linear equations. And you want to use the method of substitution in order to solve this pair of linear equations. Okay? So what you can do is that, for example, if I call this 1 and call this 2, for example, in 1 you can find x in terms of y, for example. So 7x is equal to negative 6y plus 3,800. and x is equal to negative 6/7 y plus 3800 sevenths. Or actually, what you can do, probably you can even write it as negative 6y plus 3800 divided by 7. Okay, so so that's x in terms of y. Now, since you found this in 1, now you can substitute it in 2. You can substitute x in 2. So you would get 3 times x, which is equal to 3 times this whole thing, 3 times negative 6y plus 3800 divided by 7 plus 5y is equal to 1750. And you have you will have some calculation over here. So you'll have negative 18y plus 3 times, that's 9,000. That's a 9,000 there, and then you have 2400. 2400, that's 00411 400, and then divide the whole thing by 7 plus 5y is equal to 1750, and then that's negative 18/7 y plus 11,400 divided by 7 plus 5y is equal to 1750. And then you have, it's a little bit messy actually. So 114 divided by 7, let's see if 114 is divisible by 7. So the way that you can check if a number is divisible by 7, you take away the last digit here and basically double it, subtract it from the number. So 11 minus 8 is equal to 3, right? So 3 is not divisible by 7, and so 114 is not divisible by 7, so 11,400 is not divisible by 7, and you can see it over here as well. 11,400 divided by 7 is going to give you some decimal number. So what you can do is that you can just simply add these together somehow. So you have negative 18/7 y plus 5y is equal to 1750 minus 11,400 divided by 7. And if you multiply everything by a factor of 7, you will get rid of the 7 in the denominator. So you'll get negative 18y plus 35y is equal to 1750 times 7 minus 11,400. And this number times 7 is equal to, so that there you have a 2 and 2, 15, 17. That's 17y, and 18 plus 17 is equal to 35, right? 15, 1, 35, right? Okay, so now what is 1750 times 7? 1750 times 7 is equal to 0, 35, 3. 49 plus 3 is equal to 52. And that's a 12, 250, and 250 minus 11,400 is equal to 0, 5, and then 1, 12, 8, 850. 850. So your y is equal to 850 by 17. And I don't think that this number is actually divisible by 17. I'm not really sure about that. Okay, so if you use 850 divided by 17, you will, oh, it is divisible, it's equal to 50. Okay. I don't really know what the divisibility test for 17 is. Maybe we should actually go and check what that divisibility test is for 17. Okay, so let me go over here. Yeah, I'll stop this. I'll find the divisibility test for 17 and I'll come. Okay, so it turns out that the divisibility test for 17, I don't know why it works, but the way that it works is that you have to take your number, whatever it is that you want to test the divisibility for, meaning that if you have 850 and you want to test the divisibility by 17 for this number, you take away the last digit and you have to kind of truncate your number, meaning that the last digit you take it away, 8, and you get basically 85. This is the truncated number. And then you have to take this last digit, multiply it by 5, and then whatever that is, subtract from your number. And since your number is basically 0, 5 times 0 is equal to 0, and 0 and 85 minus 0 is still going to be equal to 85. And if, suppose you don't still know whether, of course 85 is divisible by 17. Meaning that if you write 85 divided by 17, you will get a 5, right? But suppose you don't know that this number is divisible by 17. So again, you can take the last digit away, and the truncated number, you can, let's see if that works. So I mean, if the number is big enough, it does work. But here I'm going to get a negative number. Probably I should get the absolute value of the number. Let's see if that works. So 5 times 5 is equal to 25. Now 8 minus 25 is equal to 17, right? Negative 17. Of course, negative 17 is divisible by 17. And so you can conclude that 850 is actually divisible by 17. So that's the divisibility test for 17, and you can use it this way. So it's equal to 50. So now your y is equal to 50, and now I have actually forgotten what I was actually solving. Okay. So your y is equal to 15. Now you can use any of these equations, for example this one, in order to, so your y is equal to 50, and use, for example, equation number 1, 7x plus 6y, 6 times 50 is equal to 3800. And then this way you can find out what your x is. So that's 7x plus 300 is equal to 3800, and 7x is equal to 3800 minus 300, which is 3500. So x is equal to 3500 divided by 7, which is equal to 500. Makes no sense. Which makes no sense. Let me see if the answer is right. Number 3. Well, as it turns out that it is actually right, meaning that, oh, okay, so a bat costs 500 rupees and a ball costs 50 rupees, which is pretty, I mean, which I would imagine they are realistic prices, but 500 rupees for a bond would not have been a very realistic price, probably. Okay, so now the next thing that we have here is we have 3 more problems here, and I don't want to, well, actually I'm going to do them all in here and not basically I'm not going to cut this video right here, so I'll take a few minutes rest. I'll be back with you with the rest of this. So the next question is basically about the taxi charges in a city, and the taxi charges basically in this city consist of a fixed rate plus a charge for the distance covered. So you have the fixed rate plus the charges for distance covered. Okay. So now basically in this situation, for a distance of 10 kilometers, the charge paid is $105, for example, let's say. For this you pay $105. And for a journey of 15 kilometers, you pay $155. So now you want to find the fixed charges. You want to find the fixed charges and charge per kilometer, for example, per kilometer. And also you want to know how much would you have to pay? How much would you have to pay if you travel a distance of 25 kilometers? Okay, so now let's see how we can solve this problem. So you have, for example, 10 kilometers, $105, and 15 kilometers, $155. So that means that you have a fixed charge. Let's call the fixed charge. Let's call it X, and the charge per kilometer, let's call it Y. And for this first piece of information that we have here, for 10 kilometers you pay $105. So that would be basically a fixed charge of X dollars plus basically a charge per kilometer of Y dollars, and you travel for 15 kilometers, so that's 15 times Y. That's equal to, 10 times Y. So 10 times Y, that's equal to $105. And then for the second part of the information that you have the fixed charges, they don't change. And then you travel for 15 kilometers, so 15 times Y is equal to $155. So that's basically the information that you have, and you want to use the method of substitution. The method of substitution in order to solve this problem. So so from 1 you can figure out what X is in terms of Y. So X is equal to negative 10Y plus 105, and then substitute X in 2. So you have negative 10Y plus 105 plus 15y is equal to 155, and 15y minus 10y is equal to 5y is equal to 155 minus 105. So 155 minus 105 is equal to 155 minus 105 is equal to 150. That's 50. So 5y is equal to 50. So y is equal to 50 divided by 5, which is equal to 10. So y is equal to 10. Okay, so now you can substitute this back in any of these equations to get your x. So x plus 10y, for example, in 1. X plus 10y is equal to 105. So x plus 10 times 10 is equal to 105. So x plus 100 is equal to 105. And x is equal to 105 minus 100. So x is equal to 5. That means that you pay. That means that your the fixed charges is basically $5. So that means that the fixed charges are $5, and the charge per kilometer is $10. Okay, so let's see if that actually works in the case of this problem. So for example, if you go for 10 kilometers, you have the fixed charge of $5 plus 10 times 10 is equal to 100 kilometers, $100, which is equal to 105, which is basically what you have here. And now you want to know how much you would have to pay for a journey of 25 kilometers. So for a journey of 25 kilometers, you would have, so for this journey, your x is going to be equal to 5, and your y is going to be equal to, of course, 10, right? So then the cost would be equal to x, which is equal to 5 plus 25 kilometers, so 25 times 10, which is equal to 5 plus 250, which is equal to $255. So number 4. That is, the answer is correct. Now the next question that we have